Simplifying radical expressions. We got the square root of 200, a to the 6, b to the 7. No addition or subtraction signs in sight. So 3 terms. First off, you have a radical, you need to rewrite the problem. Okay, 1/2. Okay, yeah, if you see the radical, you need to rewrite it with a rational exponent. You get 200, a to the 6, b to the 7. So you have 200 times a times b. 1 times 1/2 is 1/2. 6 times 1/2 is 3. 7 times 1/2 is 3 and 1/2. So those are all positives. You bring them over. Okay, you bring in your wholes, a to the 3rd times b to the 3rd. Okay. Okay, now all your fractions, 1/2 is 1/2. So you got 200 to the 1/2 times b to the 1/2. Okay. All right. Nothing on bottom. So you got your whole. The wholes do not become radicals. Don't make them. The fractions do. They both become radical too. So 200 to the 1st times b to the 1st. Okay, so a to the 3rd will stay that way. B to the 3rd. Then you make a radical 2. Circle the 200 to the 1st and put your b to the 1st there. So you make a radical 2, and you need to set 200 to the 1st is 200. Okay. Now you try to break 200 into 2 radicals. So we're on the 2 list. So I'd start at 196. You run into decimals till you divide 200 by 100, so it'd be 102. So the square root of 100 is equal to 10. So you put 10 out here, and then 2 in here. Okay, so there you go. Okay, number 2. The 3rd root of 250, x to the 6, y to the 5th. Okay, so never said plus. Okay, you have a radical, you need to rewrite the problem. Okay, it means you make one parentheses, just 1 to the 1/3 power. And inside you put 250, x to the 6th, y to the 5th. 1 times 1/3 is 1/3. 6 times 1/3 is 2. 5 times 1/3 is 1 and 2/3. So the wholes, you have a 2 and a 1. So x to the 2 times y to the 1. Fractions, you got 1/3 and 2/3. So 1/3 has a base of 250. And 2/3 has a base of y. Okay, so x2, y1, now we put in the fractions. These are my wholes. 1/3 and 2/3, so 1/3 has a base of 250. 2/3 has a base of y, so circle those 3's. Now, can we get rid of the bottoms just by looking? Nope, 250 is not there, y is not there, so they stay for now. We'll eventually make them into radicals down here. I don't need to mess around with this. That's only if you have fraction exponents in the denominator on bottom. Alright, so that's a whole. It will not be a radical. That's a 1. That does not in a radical. Now we get rid of these 3's and we make radical 3. So the 250 to the 1 and the y to the 2nd need to be in the radical. Okay, so x to the 2, well, that can't be simplified. Y to the 1 can't be. So I make a cubed root. Now this 250 to the 1 is going to have to be simplified. The y to the 2nd cannot. So I make a cubed root. Evaluate 250 to the 1st, that's just 250. Then I make it into 2 radicals, 2 cubed roots. So 250, you'd start at 216. You remember to be on the right list. You're on the 3 list. So 125 and 2. So it's 5. So you put a 5 there and a 2 there. Okay, next problem. We have 3 radical 3 over 5y to the third times 2 with radical 3 over 50y to the fourth. Now this is a little bit different here. It's still 6 lines because there's no plus and minusing. Okay, but you need to rewrite the problem. Well, you're going to make a parentheses and get just one of them because they're both third roots, so both to the 1/3 power. Now we need to multiply the insides. 5 times 50 is 250. And y to the third, y to the fourth is y to the seventh. Now, outside you got a 3 and a 2, so you're going to multiply those and that's 6. But that's not in the parentheses. So we have numerical bases of 6 and 250. Then a variable base of y. So 6 to the 1. Put a 1, 1 times 1/3 is 1/3. And then 7 times 1/3 is 2 and 1/3. Okay, so 6 to the 1, 250 to the 1/3, y to the 2 and 1/3. Okay, so the wholes, you got 1 and 2. So 6 to the 1 times y to the 2. Now you put in your fractions, so 250 to the 1/3 times y to the 1/3. Circle the bottoms. Okay, if you look at your 3 lists, those cannot be eliminated right away. The letter can't for sure. 250 is not there, so those will have to go into radicals later. Okay. That's a whole. You're crossing this out because you have nothing on bottom to worry about. Okay. You don't want those fractions on bottom. If they're on top, it's fine. Okay, so 6 to the first, y to the second. Remember, those ones that have the full whole exponents don't get radicals, but then when we get to these, we get rid of them. They're both 3's, so I put a 3, and I put 250 to the 1 times y to the 1. Okay, so 6 to the 1 is 6. Y to the second, okay. Then you got your cubed root, and then y to the 1. But you need to simplify the 250. Now we simplified this just a little bit ago by looking at the cube list, okay. From the cube list, it's divisible by 125, so you have 125 and 2. So a 5 goes out, and then a 2 goes in. You got to take 5 times 6, and so it'd be 30 times y to the second times a cube root of 2y. Okay, number 4, hint, hint, hint. We have the 5th root of 3 times the square root of 3. The hint, this is the rewrite. It's all right there, but I'm giving you a hint because in the rewrite you need a 1/5 and a 1/2. Because they're the same. And no, you will not be multiplying the 3's together, okay? You'll be adding their powers, so you write 3 and then 1, 1. So it'd just be 1/5 plus 1/2. You add their exponents. You can't multiply bases of different exponents. You shouldn't do that. So 1/5 plus 1/2 is 7/10. Okay, it's positive, so bring it over. Okay, fraction's the only thing you got. I don't even have a 10th root, so just don't bother with the list. Then I get rid of the 10 then by making a 10th root and 3 to the 7th, okay? Now, we will not be trying to break it down because we don't even have 10th roots, but you can leave, if I don't have a 10th root, why don't you just leave it as 3 to the 7th, okay? If you know I don't have a list for 10th roots, you can just leave it. You don't have to simplify it, but you need to do the rest of the problem. Okay, number 5, another hint. We got the 4th root of y to the 6th, the 3rd root of y to the 2nd. This is the rewrite. Okay, so 1/4, 1/3. So you got y to the 6th and y to the 2nd. So you got y. Okay, 6 times 1/4 is 1 1/2. 2 times 1/3 is 2/3. So you got to cancel the 2/3. So it's 1 1/2 minus 2/3. Okay, 5/6. It's positive, so you bring it over. Okay, so fraction's all you got, but I can't really get rid of the 6 just with my sheet. Okay, but it's because you have 6 roots, but y is not going to be there. Don't need to do anything there. So now we get rid of the 6 by making a 6th root, and then inside we have y to the 5th. Okay, and you really can't simplify that. It's just a 6th root over y to the 5th. Okay, number 6, 25 to the negative 3/2 power. Again, you're using the 6 lines, but you don't do a rewrite because there's no radical. So don't try to rewrite anything. Don't make a parentheses. Don't make anything. You go with your, don't make a parentheses and put an extra power there. No, okay? You just go negative 3/2. Well, you got to switch it to positive 3/2. Now you bring that over. Circle the bottom, okay? Now, don't leave that. You need to look up and see if you can, if 25 is a perfect second root, which it is. It's 5. So now this goes away. Now the little 3 doesn't. That's going to be the exponent on our 5. So it's 5 to the 3rd power. Okay, here I'll put it over to the side. Now we have a base on bottom, but it has a whole power already, so I don't need to do anything there. We do not do a radical because that's a whole exponent, okay? You only make the ones that still have fractions into radicals. 5 to the 3rd is 1/25, and then 1 over 1/25. Okay, y to the x to the 2/7 times x to the 3/14. So again, it's going to be a 6-line problem, but if there's no radical, you don't try to rewrite anything, okay? So you have an x, okay, 2 of them means I'll add the exponents, 2/7 and 3/14. So no, if you don't have radicals, you don't be doing stuff like making your own parentheses and that stuff. Okay, I got 1/2. Ought to be pretty easy problem. Stays the same. Square root of x, you can't simplify that. But you can get rid of the 2 by making a radical 2 and then x to the 1st. Okay, and you really can't simplify it. Quick problem. Okay, number 8, 64y to the 11th, x to the 6th, and then 125y to the 4th, x to the 12th, and a 2/3 there. So it looks like a pain problem, but hey, there's no radicals, so we don't need to rewrite anything, okay? So you have 64 times y times x on top. In the denominator, we have 125 times y times x. We will cancel one of the x's and one of the y's. So 1 times 2/3 is 2/3. 1 times 2/3 is 2/3. Then y, 11 times 2/3 is 7 1/3. 4 times 2/3 is 2 2/3. Okay. On x, 6 times 2/3 is going to be 4 whole. Then 12 times 2/3 is 8 whole. Now you got to do some canceling. Okay. So the y's, you can cancel the smaller y, minus 2 2/3. That's going to be 4 2. Or no, excuse me. That's going to be 4 2/3, I think. Yep, I was right. 4 whole 2/3. Then get rid of the smaller one there, and it's x/4. So we have a whole there now. All these stay in position. So you got 64 to the 2/3 power times y to the 4 whole 2/3 power, then 125 to the 2/3 power, and then x to the whole 4th power. So you have 2 whole exponents, a 4 and a 4. So put your y to the 4 and your x to the 4 first. Because remember, these mixed numbers, you're going to you're going to have two base y's, one that's to the whole fourth, one that's to the 2/3. So now your fractions, 2/3, 2/3, so 64 to the 2/3, be circling those bottoms because we will be looking that up on my sheet. And then 125 to the 2/3. Okay, look at your third root, 64. Okay, 64 is there, dog, it's 4. So this will no longer be a fraction. It will be a 4, base 4, with a 2 power. Now the 125, the y stays obviously, but the 125 is 5. So it's 5 to the second, okay? Okay, now, we have bases on bottom with the x and the 5, but they already have whole exponents, so we don't need to make them whole when they're already whole. Alright, now, that's not a radical term, a radical factor, excuse me. Neither is that because they have full exponents. That is, we cross out the 3 and put y to the second. That's a whole, and that's a whole. Alright, now 4 to the second, 16. You got to simplify those. 5 to the second is 25. So we also have a y to the fourth and x to the fourth. Then my radical, I don't need to do a breakdown because it's just a letter. Y to the second. Okay, last problem. Well, not the last problem, but the last one where you're going to be doing the 6 lines. You have the cube root of b divided by the cube root of 2a. There's a little hint there. That means we will have to do something on this 4th line here. That's a little reminder. Now, you do need to do the rewrite. So they're both cube roots. You just make one quantity to the 1/3 power. And then you can't really simplify. It's just b and then 2 times a. So you got a base b, a base 2, a base a. They're all 1s, but they all need to be multiplied by 1/3. So they all go to the power of 1/3. Okay, they're all positive. Okay. Alright, so b to the 1/3. They're all fractions too, so just bring them all over and examine the bottom. So cube roots, I know b and a can't be cube rooted, and neither can 2. So they all stay. Now we have bases on bottom, but they're not wholes, they're rationals. You label them with r, or you can put f for fraction. I don't really care, but they have to become whole powers, the 1/3 and the 1/3. So I carry down my b to the 1/3 at the beginning. Now I put my 2 to the 1/3, and I make that a whole by taking another 2, putting a 3, and 3 minus 1 is 2. So then we multiply by 2 to the 2/3. Now, you don't multiply the 2's, you write 2 down and you add the powers, but that's always going to add to 1 whole. Then we also have that a, that needs a full exponent. It's to the 1/3. So I think I'm going to do the same thing. I'm going to put it to the 2/3. So we know that, remember to bring that on top too. The new factor that you brought into the bottom, you got to multiply. But what you multiply, the new factor you multiply the bottom by, we have to multiply on top so the fraction maintains its equivalency. Okay, and then a to the 1. Alright, these are whole exponents, so they will not need a radical. That's the point of doing it, so we don't have to make radicals in the denominator. Now all these have 3's, so those need to be lifted and placed into a cubed root. So b1, 2, 2, a2, you want to put the 2 to the second first, followed by the b to the first, and it doesn't matter the order you put the letters. Okay, now you simplify. 2 to the first is 2, a to the first, you can put a if you want. Now you don't have any outer factors on top. You put b to, you know, you're going to have to simplify the 2 to the second. So b to the 1 times a to the 2. You make a cubed root, 2 to the second is 4. Now the cubed root of 4 does not divide by any of that stuff, okay, because it's too small, so we put 4 in there. There we are. Okay, game change on the next page. We have 5 with a cubed root of 5x minus, so now I have a plus. You make it plus negative 18 cubed root of 5x. So with a plus, we just check the insides. The outside, the radicals are the same degree. They're both 3. And the insides match, which is what we need to add. They don't have to match in the other problems we did, but now they do. 8 plus negative 18 is negative 10. Done. Okay, now I've got the square root of 72 plus the square root of 32 plus the square root of 18. Now you can put 1s in front if you'd like. Okay, you don't really have to. But the insides do not match, so we can't add until we simplify them all and find the ones that do match. So 1 square root 72. 1 square root 32. 1 square root 18. So you can drop the 1 or you can just get rid of it. It doesn't really matter because you're just multiplying by 1. Okay, 72 you do on your 2 list. It divides by 36. You'd start at 64. You'd run it, so 36 and 2. So it's going to be 6 square root of 2. Then 1 square root 32. So 16 and 2. So 1 times 4 times the square root of 2. So it's going to be 4 square root 2. So we've already replaced that. I should be replacing these as I do them. Then 4 square root of 2. Nice. Now the insides match. How about that last one? Okay, so 18, wouldn't divide by 16, you have to go with 9. 18 divided by 9 is 2, so you fill that in with a 9 and a 2. So that's 3. So it's going to be 3 square root 2. So all the radicals are the same. And 4, 3, that's 10, and then plus 3 is 13. Okay, I forgot to write a few things here for you. You'll be applying the FOIL method here. I will have that on the test. And also, you will see me writing 1 square root 50, and that means that needs to be broken down before you go to the FOIL. Okay? It's because we're timesing, but 1, 1. Before you FOIL, you need to break down any radicals, and the 1 square root of 50 definitely needs a breakdown. So on that list, 50 would divide by 25, so it would be 25 and 2. So the square root of 25 is 5. Then 1 times 5 is 5 square root 2. So you need to rewrite that problem. So now that's 8 plus 5 square root of 2 times 2 plus 1 square root of 2. Okay, first you multiply. 8 times 2, 8 times 1 square root of 2, 5 square root of 2 times 2, and 5 square root of 2 times 1 square root of 2. So that's 16. 8 times 1 is 8. You just attach the square root of 2 onto it. 5 times 2 is 10. You attach the square root of 2. Now, 5 times 1 is 5, but you need, in multiplication, you actually have to multiply the 2 square roots together, and that's 4. But then that's not simplified because that would be turned into 5 times 2, which is 10. Now you're adding. You just multiplied there, now you're adding, okay? So 16 and 10 obviously would add to 26. And I put a plus sign because I'm adding, and I put radical 2 down. Now you leave it at radical 2 because now you're adding. When you're adding, you leave it at the radical it's at. When you're multiplying, you got to multiply the radicals. So it's going to be 8 plus 10 is 18. Now you're not adding anything after that, okay? This is, if it was a times, you take 26 times 18 and connect the radical 2, but in adding, you can't add because that doesn't have a radical, that one does. It's like trying to add a 26 plus an 18x, doesn't work. Okay, minus, make it plus negative, put a 1, and again plus, you got to match up the inside. So you got the square root of 300, and then 1 square root, negative 1, excuse me, square root 75. So I don't have a coefficient. You could put a 1 if it's driving you nuts. Okay. So 300 up the list, it eventually divides by 100, so you fill it in with 103. So the square root of 100 is 10. So you have 10 square root of 3 plus negative 1 needs to be dropped. Okay. And 75 would divide by 25, and that's 3, so it'd be 25 and 3. Okay, square root of 25 is 5. So negative 1 times 5 is negative 5 square root of 3. Okay, so the insides, you have the square root of 3, 10 plus negative 5 is 5. Okay. Alright, and that's adding, so far 2 parts, multiplying and dividing, and adding is just making sure they're the same. Now you're solving equations, you're trying to find what x equals. Okay, there might be 2 answers, okay, whatever. Okay, so we have x in a radical, so we're going to circle the radical. Now, before I worry about the radical, I've got operations outside. You got a times 3 and a minus 3. So first we have to get rid of the minus plus. We minus 3, we have to plus 3. And then we have to divide by 3. Then we'll be able to do the 2 power. Just get it to 2x. So plus 3. Takes that side to 12. Then you divide by 3. So that's 4. So you got the square root of 2x. Now you do your 2 power. So now we just have 2x. Please remember to take 4 times itself. Don't just leave it 4, 16. Okay, well there's only one answer because it's x to the first, so it's linear properties. So you divide by 2 and you get 8, x equals 8. Okay, number 15. Now you have a parentheses of 2x plus 3. That's a 3/4 power. Minus 3 equals 5. Now, when I have one parentheses to a power, again, I'm still solving for x. Might be 2, might be 1. Okay. You want to replace that with h. So h to the power of 3/4 minus 3 equals 5. Now you're going to make a table, and you're going to bring back the 2x plus 3. Maybe it's on both sides, maybe it's not. Question mark on the right. That'll depend on what kind of a root I end with, but I don't know at this point. So I plus 3 takes us to 8. I get rid of my 3/4 power with a 4/3 power. Now, remember how we do evaluate this the same way. That is an odd root that I will be looking up. So I will not need this side. Had that been an even on the bottom, I would need both sides. But it's odd, so I look up the 3rd root of 8, and that's 2. But remember, I've still got 2 to the 4th, so I need to evaluate 2 to the 4th, and that's 16. So I place 16 here. That ain't the answer for x. That's what the quantity is equal to. Then I apply linear properties. Minus 3, that's 13. Divide by 2. It's going to be a decimal, 6.5, so I'm fine with that. Okay, then this one. The square root of x plus 7 equals x plus 1. So again, now we're back to having a radical. Okay, we don't use h for radicals. Anything outside the radical? Nope. So 2 power right off the bat. So these cancel. we don't get a cancel on that side. This side you just write x plus 7. The side that didn't have the radical, you actually have to find the product. So it's a binomial to the second instead of just a value to the second. So you take FOIL, x times x, x times 1, 1 times x, 1 times 1. X second, 1x, 1x, and 1. Okay, so we get x to the second plus 2x plus 1. Okay, now it's quite apparent here we have two answers. It's also quite apparent since we have x along with x to the second, we need to apply factoring properties, not the linear properties that we did over here. Okay. So you need to clear the side that does not have the x squared. Minus 1x with the 2x, minus 7 with your 1. So you have 1x to the second plus 1x. 1 minus 7 is negative 6. Now you factor. GCF will just be 1. Okay. And then the t-chart. So 1 times negative 6 is negative 6. So it's a positive times a negative. It adds to make positive 1. 1 and negative 6 won't work. Positive, negative, divide by 2, you get 3. Now that adds to negative 1. You got to make it positive 1 by making the 3 plus and the 2 a negative. Okay, so we have a minus 2 and a plus 3. Alright, it was just 1x to the second, so x, and we don't do anything there, so this is just rewritten as x minus 2 times x plus 3. Okay, so x minus 2 could equal 0, x plus 3 could equal 0. So I get 2 and negative 3. Okay, graph the function, identify the domain and range. Put domain and range over here. Okay, so again, just set up your parent radical function. That's just the radical over the x without the outsides. Now do an input-output table, but you can't do negatives and only pick the perfect squares, first 3 perfect squares. It's 3, 2, 1. Okay, now, in the radical, you have nothing other than the x, so the x stays at those inputs. But outside, you got a times 3 and a minus 2. So, outside, remember what the outside does. It does the same operation to the y. So all my y values have to be multiplied by 3 and then minus 2. So 3 times 3 is 9, minus 2 is 7. 6 minus 2 is 4. 2. Some of you good at mental math, put a 9 in. Square root of 9 is 3. 3 times 3 is 9. 9 minus 2 is 7. Okay? So 0, 2 is the restriction point. And you can just go by ones. Okay? Wait a second, I kind of forgot the 1 here. 1 times 3 is 3. It's just going to be to negative 2. This is going to be a 1 here. Okay, I messed that up, sorry. Okay, then 1, 1. So it's a negative 2. Sorry, I jacked that up. 0, negative 2. Because 1 times 3 is... yeah, it's a 0. 3, 2, 1, 0. Okay. So it goes 7, 4, 1, negative 2. Sorry about that. I don't want to restart the video after 30 minutes in. Okay, 1, 1. 4, 4. And then 9, 7. 1, 2, 3, 4, 5, 6, 7. 9, 1, 2, 3, 4, 5, 6, 7. Okay, so that's right. Alright, domain range. So 0 is your x, negative 2 is your y. So we're just getting higher on the x, okay? And from -2, you're getting higher on the y. Okay, all the y values are greater than. Or you can do your little split to the right, above. Right's greater than, above's greater. Okay, y equals the square root of x plus 4 minus 7. Let's see if I can get this down this time. Okay. Same setup, because it's a square root. You will not see any of that 1, 8, 27 garbage. So 1, 4, 9, 3, 2, 1, 0. Now, inside the radical, you got a plus 4. Remember, inside operations do the opposite operation to our x. So if I see we have a plus 4, I will be doing a minus 4. Now outside operations, we have the minus 5. That does the same thing to the y. So 9 minus 4 is 5, 4 minus 4 is 0, 1 minus 4 is -3, 0 minus 4 is -4. -2, -3, -4, -5. Okay? Alright, this is my restriction point. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Then -3, 4, 1, 2, 3, 1, 2, 3, 4, 0, -3, and then 5, -2. Now, you keep going this way, but this side you can't do anything to the left of that because that that gives me negative values inside of the radical. Okay, domain range. So x, y. Okay, so -4 is my x, -5 is my y. Now from the -4, these are bigger than -4, so greater than or equal. From the -5, these are bigger than negative. Remember, the smaller negative, the bigger it is. So those are greater than or equal.